Welcome to Electricity and Magnetism, Part 8a, Ohm's Law. As you can see on your screen, Ohm's Law is V equals I times R, or voltage equals amperage times resistance. And you see the definition for each of the symbols on your screen. Let's do a quick little example here. What voltage is needed to drive an electric motor that draws 10 amps of current and has 75 ohms resistance? Ohm's law, 10 amps times 75 ohms gives us a voltage of 750 volts. Ohm's law applies to each component in the circuit as well as the whole circuit. What does that mean? That means if you know the total resistance of the circuit and the amperage supplied, you can find the voltage that is supplied to the circuit. By the same token, knowing the resistance of a component in a circuit and the amperage through it, you can calculate the voltage that's used up as current passes through that particular component. Now, we talk about voltage drops in a circuit, and a voltage drop is the voltage used, or actually the energy used, to move current through a component in a circuit. Light bulbs, for example, require energy to make them glow, and we measure the amount of energy used as voltage. So if 100 volts goes into a light bulb and 10 volts is left when the current leaves the light bulb, 90 volts has been used to light the bulb. We say there's a 90 volt voltage drop through that particular light bulb. Now, when you have more than one component in a circuit, the sum of the voltage drops in a circuit equals the voltage supplied to the circuit. What exactly does that mean? We're going to take a look at a little example here, a very simple one. We have a two-component circuit, R1 and R2, and we have a 100 volt power supply that supplies 2 amps of current. When the current leaves the power supply, it's going to flow through R1. It's going to use up some amount of voltage to move the current through there. Current continues, goes through R2. Again, it's going to use up some kind of voltage. Go back to the power supply. If you add the voltage drop through R1 to the voltage drop through R2, you're going to find it equals 100 volts. Now, how are we going to find the voltage drop? Well, we're going to use Ohm's law. V equals IR. We know the resistance of this resistor right here, it's given as 10 ohms. We know it's 2 amps, so we can use Ohm's law to calculate the voltage drop right here. Okay, let's try an example. Redrew the sample circuit that you see there, two resistors, 100 volts applied at 2 amps, and we want to find the voltage drop across R1. Now I'm going to use Ohm's law. I'm going to say that the voltage drop across R1 is equal to the current through R1 times resistance of R1. V1 is equal to 2 amps. This is a series circuit, so all the current that leaves the power supply flows through both resistors, times resistance of R1, which is 10 ohms, which is given. It says we have a 20 volt drop going through this resistor, which means 100 volts goes in, 20 volts are used on the inside, and 80 volts leave the resistor. Example number 3 here. Find the value of R2. Well, voltage drop 2 is equal to current times R2. We know that 100 volts went into the R1, 20 volts came out, which gives us 80 volts coming out of R1. We know the current is 2 amps and resistance R2 is the unknown. Rearrange, do the arithmetic, we find that R2 is equal to 40 ohms.